Hello everyone. So today we're going to be talking about segment addition postulate, angle addition postulate, midpoint, bisectors, and review of distance formula. So segment addition postulate, which we will from now on abbreviate to SAP, says that if B is between A and C, then AB plus BC equals AC. We can also say it in the reverse order, but all we're saying is if you add up the two parts of the segment, it equals the whole segment. Let's try an example. If AB equals 5 and BC equals 15, then what is AC? So the first thing I'm going to do is draw my picture and label my parts. So AB is 5 and BC is 15. Well, using the segment addition postulate, we know that AB plus BC is equal to AC. So if I just substitute in what I have, AB is 5 and BC is 15, then that means my whole segment AC is equal to 20. Now, angle addition postulate, which from now on will be abbreviated to AAP, says the same thing as segment addition, just for angles. So if P is in the interior of RST, so just if you have a point in the interior of the angle, then RSP plus PST equals the whole angle, RST. So we can add up the pieces of an angle to equal a whole angle. Let's try an example. So if the measure of angle RSP is equal to 30 degrees, and the measure of angle PST is equal to 40 degrees, then what is the measure of angle RST? So the first thing I need to do is draw my picture and label my parts. So I'm going to draw angle RST with P somewhere in the middle, and then label my 30-degree angle and my 40-degree angle. Now we know, using angle addition postulate, that if we add the two pieces of the angle together, it'll equal the whole angle. And then when I substitute what I know, the 30 degrees and the 40 degrees, then that means my whole angle is going to be equal to 70 degrees. Let's look at a few examples. First, line L is a segment bisector. Find EG if EF is equal to 13 centimeters. So we know from before that a segment bisector cuts a segment in half. So if EF is equal to 13 centimeters, then FG is equal to 13 centimeters. So EF equals FG. We know from the segment addition postulate that I can add up the two parts, EF plus FG, and set it equal to the whole, EG. Then I'm going to substitute in the numbers that I know. EG is equal to now 13 plus 13, so that means that our answer, EG, is equal to 26 centimeters. Let's look at the next one. Find JM if M is the midpoint of JL. We know that the midpoint is in the middle of the segment, so it divides it into two equal pieces. So that means that JM is equal to ML. So I can just take their equations, 6x plus 7 and 4x plus 5, and set them equal to each other. Now all I need to do is solve. So first I'm going to subtract 4 from both sides, so that leaves me with 2x plus 7 equals 5. And then I'm going to subtract 7 from both sides, so I have 2x equals negative 2. And then when I divide by 2, x is equal to negative 1. Now, is this what they asked us for? And the answer is no. They asked us to find Jm. So we need to plug back in. So Jm is equal to 6 times negative 1 plus 7. So when I simplify it, that means that Jm is equal to 1. Let's try another example that uses a lot of the things we've learned so far. Use the figure to answer the following questions. First, find y. Second, find AB. Third, find x. And then fourth, find the measure of angle BDC. So we start with finding y. If you notice, y is a part of the length of AD and DB. Also, you see these tick marks that we discussed before, so that means AD is equal to DB. So this means I can set their two measures equal to each other. So y plus 20 is equal to 5y minus 4. So now we need to solve. First, I'm going to subtract 20 from both sides. So I'll have y is equal to 5y minus 24. Then, when I subtract 5y from both sides, I'll get negative 4y is equal to negative 24. Then, when I divide both sides by negative 4, that gives me y is equal to 6. Now, let's find AB. So AB is a segment, so we can use segment addition postulate to say that AD plus DB is equal to AB. So I'm going to take y plus 20 plus 5y minus 4 and set it equal to AB. Then, since I know that y is equal to 6, I'm going to plug in 6 for each time I see y. When I simplify, I see that 26 plus 26 is equal to AB, and so that means that AB is equal to 52. Now look at number 3, find x. If you notice, x is a part of each of these angles, and we have a right angle right here. So pause the video and try to find x on your own. So you might have noticed that EDC and CDB are complementary because we have a right angle right here, so that means that this is also a right angle because those two lines are perpendicular. So that means that 2x plus 3x minus 10 is equal to 90 degrees. So I need to combine my like terms, 2x and 3x. So I'll have 5x minus 10 is equal to 90. Then I need to add 10 to both sides, so I'll have 5x is equal to 100. And when I divide both sides by 5, I find that x is equal to 20. Hopefully you got that one correct. Now try number 4 on your own. Find the measure of angle BDC. So we know that BDC is equal to 3x minus 10 because it's labeled as such in the picture we were given. Since I know x is equal to 20, then I can plug in for x, so I get 3 times 20 minus 10 is equal to the measure of angle BDC. So 60 minus 10 is equal to the measure of angle BDC, and so that means that the measure of angle BDC is equal to 50 degrees. Now let's talk about an angle bisector. An angle bisector is much like a segment bisector. The bisector cuts the angle in half, leaving us 2 congruent pieces. Whenever we have congruent angles, we add in little arcs like such to each of the angles to show that they're congruent. So now let's try an example. Given that ray BP bisects angle ABC, find the measure of angle ABC. So again, we see right here that since it bisects, I've marked these 2 angles congruent with these little arcs inside the angle. So that is me saying that the measure of angle ABP is equal to the measure of angle CBP. So I can take the given measures, x plus 15, and set it equal to 4x minus 45. So now I need to solve. First, I'm going to subtract x from both sides, so that leaves me with 15 is equal to 3x minus 45. Then I'm going to add 45 to both sides, so I'm going to have 60 is equal to 3x. And then when I divide both sides by 3, I find that x is equal to 20. Now again, that's not what it asked us for, because they asked us to find the measure of angle ABC. So I can now write the equation, the measure of angle ABC is equal to 2 times the measure of angle ABP. I can write this because I know I have 2 congruent angles, so they would both have the same measure. So whether I add the 2 angles to equal the larger one, or I multiply one piece by 2, since they're both congruent, I'm going to get the same answer both ways. Now I'm going to plug in for measure of angle ABP. So I have 2 times x plus 15. I've already solved for x. I know it's 20, so I can plug that in. And then when I simplify, I find that my answer is 70 degrees. Now this should be a refresher. I know that you have learned distance formula before. The distance formula is used to find the distance between 2 points x1, y1 and x2, y2. So here is our formula right here. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's do one example. Find AB. So we're looking for the distance AB. If we look, A is at -1, -1, and B is at 2, 3. So we're finding the distance between A and B, which is just the capital letters AB with no bar above it because we're discussing length. And now I'm going to plug into my formula. So I'm going to use B as my x2, y2, and A is my x1, y1. So my formula, AB, is equal to the square root of 2 minus -1 squared plus 3 minus -1 squared. Now you might know when we have a minus a negative, that's the same thing as adding. So I have the square root of 2 plus 1 squared plus 3 plus 1 squared. So I can simplify this further to the square root of 3 squared plus 4 squared. So we have the square root of 9 plus 16, which simplifies to the square root of 25. So that means the length of AB is equal to 5. And that is the end of this video. See you in class.